Okay, in this section, we're going to calculate compound interest. Compound interest, last previous section, we discussed about simple interest, which is just one-time interest. Compound interest means here we're going to calculate interest for the interest as well. So these are the objective. Compound interest formula, there are formulas, and then depending on that we also calculate present value. And finally, what is the effective annual yield, which is what is the simple interest rate if we use the compound interest formula. That is also going to be calculated in this section. So what is compound interest? It's the interest computed on the original principal as well as on any accumulated interest. So it's interest over interest. For example, let's say you invest $1,000. Okay, $1,000 in an account which gives you annual interest rate 4%. So that means the simple interest is 1,000 times 0.04 for 1 year. Okay, and depending on how long you are going to put that money or invest that money, let's say you are investing that money 5 years, then eventually we are just going to calculate this value, just multiply this value, and it's going to give you the simple interest. The difference between the simple interest and compound interest is, depending on the package, now you are going to calculate this interest every single, for example, maybe monthly or maybe quarterly or maybe yearly, depending on information you have given. So now let's say compound interest calculated yearly. Then what happens is, after a year we do the calculation for the interest after a year using the simple interest formula, and then that would be what is that? That would be 1,000 1,000 times 0.04 means it's a $40. So after a year, let's say if you multiply 1,000 times 0.04 bucks, sorry about that, it's 1,000 times 0.04, that's a 4% of the $1,000. After a year you are going to make $40 interest. Now for the remaining time, like next year, you're going to calculate the interest for $1,040, not for the $1,000, because next year you already have accumulated interest $40 for the next year. So you do the same operation again and again, and that is you are getting the interest over interest, and that is called compound interest. So interest is compounding. Is there any direct formula to do this calculation? The answer is yes. To calculate the compound interest paid once a year, this is the simple formula. So that is principal times 1 plus rate to the power how many years you are going to use that formula for. For example, in this scenario, if you are investing $1,000 with a 4% interest rate for 5 years, which is compounded yearly, this is just for the yearly, okay? Then how do you calculate how much money you are going to get at the end of the 5 years? So A is the value, the future value is $1,000, 1 plus interest rate 0.04 to the power 5. So this is $1,000 times 1.04 to the power 5. So 1.04 to the power 5 times $1,000 gives you 1,216 bucks 65 cents approximately. This is the amount you are going to get after 5 years using the compound interest formula. A is the future value, P is the principal, and R is the interest rate, T is the number of years. So the notations are very similar to the previous section. What if instead of yearly compounding, if you have different packets which compounds n times per year? It could be daily, it could be monthly, it could be quarterly, depending on the value of n. You can use this formula. So this is the formula for compounded n times a year. So what is n? If you are compounding monthly, then how many months are there in a year? 12 months. So that is the value you are going to use. This is yearly. If you are compounding, let's say daily, then you might have to use 360 days. According to the banker's rule, you might have to use 360 days. So if you are compounding quarterly, then 4 quarters are there. So n, the value of n would be 4. So depending on how many times in a year you are compounding, you replace this n by that number. T stands for the time in years, R stands for the rate, P stands for the principal, and A stands for the future value. Same thing, the only difference is n. So there are two different scenarios when we use the compound interest formula. One is compounding n times. This is the formula you're going to use. But sometimes what happens is we use continuous compounding. Continuous compounding means the value of n is indefinitely, meaning every single moment we would like to compound it. In that case, this formula becomes a equal p times e to the power r times t. E is this E you are talking about. Look, this E, 2.7182, it's a irrational number. So that is what you have to use. So whenever you read a problem, if the question says compounding, you just have to keep in mind compounding n times or compounding continuous. If it's continuous, if there is this word, then you use this formula. If compounding n times, you need to find out the value of n and you need to use this formula. So let's say the future value is given and then interest rate is given, n is given, everything else is given, and then you need to find out the present value. This is the formula you are going to use. The scenario is, let's say for example, in 5 years you would like to make a purchase of some very expensive thing which cost let's say $100,000. Then you want to save for this purchase from today. So you have 5 years. So you go to different banks or different investment, and you find out that there is a package which pays you, let's say, 4% a year. Then with this information, 4% a year, let's say compounding per month, that is the package. How much money you need to invest today so that you will have $100,000 in 5 years with 4% compounding monthly? To calculate this information, you go here and you just put $100,000, 1 plus the rate is 0.4. It's a monthly in my example, so I'm going to replace n by 12. So 12 times 5 years is 60. This is the calculation I have to do. How do you do that? Type 100,000 divide parenthesis 1 plus 0.04 divide 12 parenthesis close power 60. If you hit enter, that means you need to invest 81,900 today to make 100,000 in 5 years with this package. Okay, that's called principal present value. Now this is very, very useful. Effective annual yield. Let's say you invest some money today. For example, if you go back to this example we were doing, what is that? This one. Let's say you invest $1,000 for next 5 years with 4% compound yearly package. Finally, you are going to get $1,216.65. So this means this $1,000 becomes $1,265. Let me just make sure that $1,216.65. $16.65. $16.65. To get this, we use compounding yearly package with 4% interest rate for 5 years. But we would like to find out what is the simple interest rate which gives us $1,000 to this amount in 5 years. Just the simple interest rate. So you are going to use this formula, interest equal to principal times rate times time, to find out the simple interest rate. What is the interest we made here in this transaction? The interest is $216.65. What's the principal? $1,000. We don't know the rate. The time is 5. This rate is simple interest rate we would like to calculate. This rate is compounding interest rate per year. But here we are interested to find out the effective annual yield, which means the simple interest rate for that particular package. So to find the R, just divide both sides by 5,000, because 1,000 times 5 is 5,000. So it's a $216.65 divided by 5,000 is 0.0433. 0.0433, which means it's a 4.33%. So the effective annual yield or effective rate is 4.33%. This is the most useful information whenever you try to compare different packages, which one gives you the more money. This information is very crucial. Just compare the effective annual yield, and then whichever is greater, that gives you the more money. Okay, let's do some more problems from your homework assignments. Let me just add some blank pages here, and let's go to your homework problem. Fill in the blanks so that the resulting statement is true. Compound interest is computed on the original principal as well as any accumulated interest. Yes, it's a principal plus interest. You get interest from the principal and then interest itself. Interest over interest. That's why it's called compounded. The principal represents an amount of money deposited in a saving account subject to compound interest at the given rate. So you have $10,000 principal, rate is 1.5%, compounded daily. How much money you are going to get after 16 years? So remember, the formula is this one, compounded n times a year. In our case, it's compounded daily. So I'm going to copy the formula first. The formula is the future value is principal times 1 plus rate over n to the power n times t. In this question, the principal is $10,000. Okay, rate is 1.5%, which is 0.015. N means it's a daily, so we are going to use 360 days in a year. N times t is a 360 times 16. So we are going to do that calculation first. 360 times 16, because there are 16 years, that is 5,760. 5,760. Now the future value would be, just type this one, so 10,000 times parenthesis 1 plus 0.015 divided by 360 parenthesis close Power, where is the power? Power 5760, and that is the amount you are going to get, which is 12,712.42. So let's see what they are looking for. Nearest cent. So 12,712.43. 12,712.43 cents. Okay, find the interest earned. The interest is the difference between these two amounts, which is 2,712.43. That was the interest earned in 16 years. So we are done for that. Let's do this is semi-annually, means the n equal to twice a year. An account has a rate of 4.2%. So the same formula, interest rate is 0.042. We need to find out the effective annual yield. The n is 2 because semi-annually means there are two. The value of n would be 2 twice a year. Then effective annual yield means how much simple interest you will get from this transaction. So let's say 0.042 n equal to, an account has a rate of 4.2. What is the effective annual yield? So how do you calculate this thing? How much it becomes? So R is let's say okay, I forgot to mention one formula before about effective annual yield. I did go over this concept, but there is a formula for finding the effective annual rate. If you know the interest rate and then how many times you compound, this is the formula. Effective annual rate is equal to 1 plus interest rate over n to the power n minus 1. So we're going to use that here in this. Effective annual rate is 1 plus r over n to the power n minus 1. In this case, r is 0.042, n is 2, 2 minus 1. We just need to do this calculation, which is, let's say, parenthesis 1 plus 0.042 divided by 2 to the power no 1 plus, okay, I need the parenthesis, 1 plus 0.042 divided by 2 to the power 2 minus 1. That gives you effective annual yield, which is 0.042442441, which means it's a 4.224%. So if you go back to this problem, round to the nearest 100, nearest 100 means it's a 4.224. 4.22, that's the nearest 100th. After decimal, you just need, what did I do wrong here? Let me go back again. It's a 4.24, sorry, my bad, it's a 24, not 22, 24. I did not copy the number properly. That's how you can find the effective annual interest rate. This is the one more question. At the time of her grandson's birth, a grandmother deposited $10,000 in an account that pays 6% compounded monthly. What will be the value of the account at the child's 21st birthday? Assume that no other deposit or withdrawal are made. So use the very same formula, the compounding monthly formula. We know A equal P times 1 plus R over n to the power n times t. In this case, original principal is $10,000. interest rate is 6%, compounded monthly, so n equal 2, and then it's for 21st birthday, so 21 year times 12, that's n times t. 21 times 12 is 252 months, 252. So what is the value here? Calculate this, just type this, 10,000 times parenthesis 1 plus 0.06 divided by 12 parenthesis close power 252, and that's 35,143, and if you round it to the nearest dollar, it's a 35,144. 35,144. Okay, that's all for this section.